Okay, a roof is in the shape of a square-based pyramid. Square base is side 6. Four triangular faces are congruent to each other with AP equal BP. So the slant height's 11. Use Pythagoras to show that OB is 3 root 2 and hence find the value of OP, the height of the pyramid. And we want OB first. Okay, so OB. Three. So that's a 3 squared plus 3 squared equals OB squared. OB squared equals 18. So OB is root 18, which is root 9 times 2, which is 3 root 2. And then find OP, which we'll call H. So we'll say H squared plus the OB squared, which is 18, should equal the slant height squared. So 11 squared minus 18, and then root in Cert form. So H is root 103. Yeah. On this triangular face, PAB, the size of the angle PAB is 74. PAB 74. Use this or otherwise work out the total area of the four triangular faces. Well, I just have to get it for 1, right? So I'll just use the good old formula, a half AB sine C. So what's that now? 6. And we have the slant height, don't we? It's 11. So it's a half 11 6. A half 11 6 sine 74.2 times 4. Is that right? To the nearest meter squared. 127 meters squared, is it? The diagram below shows parts of a scale diagram of the net of this pyramid. The diagram shows the square base and 2 triangular sides. Construct the rest of the scale diagram of the net of the pyramid. They're all congruent. 6, 6. Yeah, okay. So I guess I could just do a symmetry job here. I could just do my 2 compass arcs here to get the perpendicular. Draw the perpendicular line, and then set my compass to this length and mark it off here, and then draw there with my ruler. So that's fine. And then I can I just want to copy, I want to get this one down here. Or again, I guess I could just, I mean, it's my net, so I guess I could just duplicate this on the left by doing another arc here, drawing a perpendicular line, setting the height here, marking it off there, and then copying it down. I think that's fine. In the diagram on the right represents a flagpole, 15.7.5. Ali measures that CAB, the angle of elevation of the flagpole. She makes some mistakes and measures that CAB is 52 degrees, which is not correct. Work out the percentage error. So tan inverse of 17.5 over 15 is not very far off, 49.398, etc. So the error would be 1.601 over 49.398 times 100. So it's the answer is 3.2% too big. Okay. Ali is also working at the height of a round tower. She measures the angle of elevation to the top of the tower. She then moves 10 meters closer. She measures both these. This is a classic elevation question. She draws the diagram below. Two lengths are shown in the diagram. Use the sine rule to show that x is 22.5. Well, the first thing I always like to do is get in all the angles. So that's 90. That's 90. And that there is 55. So that's 145. That's 13. So it's sine 13 over 10 equals sine 145 over x. So sine 145 times 10 divided by sine 13. And by solving this, you'll get x is 25.5. So that's fine. Hence, find the total height of the tower. So now that we have x, we can just draw this triangle here. The x is 25.5. And then the base, we don't know. But I guess we don't need to know it because we know that that's 22 degrees and that's h. Right, that's 22. So what will I use? Just tan? Tan 22 equals h over 25.5. So h is 25.5 tan 22. So if I just multiply my previous answer by tan 22, I get 10.3. But let's not forget to add on the 1.25, because technically I'm not really getting h, I'm getting this height here, which I'll call capital H maybe to distinguish it a bit. So then the actual h, I want to add on 1.25. So I get 11.6 meters. Does that look reasonable? I guess so. Oh, it's at the end of the question. Yeah. Okay. Okie dokie. There's a mistake. Two mistakes in question 8. Although those were my only 2 slips. Not bad for running through the paper quickly and being very tired. And in fact, wouldn't actually affect my grade, because I assume if you answer all the questions, you get the best marks, because you only had to do 3 from section B. But I made 2 silly mistakes here. Let me fix them in red. Where is it now? Where was it now? Where was it? There was the one with the error. Yeah, here. Where's my calculator? Yeah, why did I say 1.601 was the error? It's tan inverse 17.5 divided by 15, which is 49. So that's right. And then if I subtract 52, I must have subtracted 51. That should be 2. So it's not 3.2%. It is too big by 5.3%. So that's fine. And a silly little mistake here. I can't believe I've done this. I must have been so tired. Mixed up tan and sine? Because that's opposite over hypotenuse. So that should have been a sine. So it should have been a sine here. 25.5 sine 22. So that is slightly different. 9 0.6 meters. So thank you, Connor, for grabbing those two mistakes. Tan sign slip, and don't know what happened here. Must have been a mistyping on the calculator. I must have typed in 51 instead of 52. So hopefully that's the only two errors.